The world is not a perfect place. Sometimes things go wrong that we hadn't expected. In fact, sometimes things go wrong that we did expect. So before we go much further, I'm going to give you a powerful tool, a new type of code block, that is going to be able to express to the Java compiler to not break for things that you expected might go wrong. How many times have you seen this before? We call this, again, a stack trace. And I'm sure you've seen this before and you understand the errors part of it, but you also see another key word here. It says exception. In this case, it's a runtime exception. And of course, why do we have an exception? Because something went wrong. Maybe we have a null pointer exception because we actually have a variable that isn't pointing to something in memory, and we're trying to call a method on null. Well, there's basically two types of errors that we want to deal with. There are things called checked errors, and there are things that are unchecked. Technically, there's three types of error situations in general. There are things that we expected to go wrong, that might go wrong, that are things that are built into our code. Then there are actual just errors, things that went wrong because somebody else's code perhaps broke. And then there are things that went wrong because our code does not work. I like to think of these things in terms of just checked errors and runtime errors. Checked errors would be for things like, oh, I'm trying to read from the disk, as is somebody else, and my file is not where I thought it was while I was reading it. Or the network is too slow, and I didn't actually get to that web page, I got a 404 error. Or I can't connect to the server at all. Those things fall under checked errors. There are things where it's like, hey, try to get a network connection, and if you can't, that's okay. We'll just have to do something different, like let the user know to turn on their Wi-Fi or connect to a different Wi-Fi hotspot. Then there are unchecked errors, runtime errors. These are things that happen while the application is running. These are things that you need to account for and that you should make sure never happen to the user. So in order to deal with these things, there's a little thing called try, catch, and finally. Try, catch, finally works like this. This block will try to be run. Doesn't matter how many lines there are in here. If we were going to actually do something, and let's say the doChecked method didn't work. Line 3, or I guess in this case, let me make that line 4. Line 4 will not run, but your app won't crash either. What will happen is after line 3, this will fail, and catch, this block down here, will be run instead. Again, you can put as many things in that particular block that you want, but you'll often see this idea of catch, exception, E, and then print the stack trace. Yes, an exception is an object. In this case, it's like it's being passed in as a parameter. What you can expect with an exception object is it's an object we use to kind of describe what happened with that error. Why did it go wrong? And there's many different types of classes that inherit from the major exception class. So when you try something, you can then catch the exception. And if you look at the code that actually throws exceptions, you'll see another keyword, throw. So it's almost like you have this idea of there's an error, and the exception gets thrown into the catch block. That's why if you look over here in the actual log for an error, you see all these different lines. The stack trace is actually the different levels of methods that you are inside when something goes wrong. Here we can see that main activity.java on line 41, something went wrong. But that's because we were also inside all of these other different methods. So exceptions actually get thrown up through that stack and allow us to say, I don't really care what happened in doChecked. I don't care how many levels deep something went wrong. Ultimately, they'll percolate up to the top where you can catch them and then do something about them. Now remember, when you do this, don't use catch to just scrub out something that is broken. The catch block is for things that you know should actually go wrong, such as the network doesn't work or things like that. You don't want to use the try and catch block to just cover up runtime problems. This will make your application incredibly brittle, incredibly hard to debug. They're not to patch things up. They're to expect when you want to try to do something, but expect that sometimes it may not work, and then respond accordingly. So then, what's with this finally block? Well, the finally block is literally what it says. It is a block that will run finally, regardless of the situation for try and catch. We're going to use the finally block a little more as we get into network later on. But for now, just expect that the order of operations will be try to do something, catch it if something goes wrong, finally do these particular lines of code, if and only if you're done with the previous two blocks. One thing that you'll also notice about doing unchecked exceptions versus checked exceptions, a checked exception method, like this one, that throws an exception, actually will not be able to be done outside of a try-catch block. You'll get an error. This is a way that you can communicate through your code that, hey, I need you to handle exceptional conditions. What you need to do when you have a red line like this, where it says unhandled exception, is take it, put it in a try and catch block, and be very careful that the type of exception that you have here is the correct one. Now in this particular type, I'm throwing just a regular exception. If I was, however, throwing a type of exception that extended from exception, like IO exception, then I can still catch the general exception here. But I also might want to do something very specific for that particular situation. Using multiple catch blocks, I can say, in case of an IO exception, do something very specific. And in the case of another exception, such as an end of file exception, do something different. Maybe here I want to say to the user, I reached the end of the file. Here, you might want to say, your disk drive is broken. Using this particular methodology of catch and exceptions will allow you to handle particular situations that you know might or might not work out, and provide a consistent user experience to the user in a way that they think everything is seamless.